Hello and welcome to Unit 8 of the main course Remote Update of Programs and Functionalities. Today we are going to talk about remote updates over a secure connection. So what is necessary to be able to update a PLC when you're not on site but somewhere remotely and want to update the system. So what will be the content of today? The need for security. Why do we need special devices to connect our PLCs to the internet? We will talk about industrial switches and routers and their differences, the typical applications of a router, and finally a little bit of setup for routers and also the industrial switches from Siemens. So you should be able to explain how to do updates over secure connection, mainly why we need security in an industrial environment, explain the differences between switches and routers, setting up such a router, and setting up an industrial firewall, at least the basics. So let's start with the need for security. Maybe you've heard the terms information technology and operation technology. IT is something that is quite common to us, where we have a lot of computers in our offices that we are going to work with. Nowadays, we also have a lot of computers in our production area. And for this, the term operation technology was created, sounding similar to information technology. Information technology normally deals with data processing that is using software, and we also deal with hardware and communication technology. Typically, IT departments do not care that much about hardware, at least not hardware production or embedded systems. And this is something that is totally different for operation technology, where the hardware normally is directly connected, so the computer hardware is directly connected to some physical mechanical hardware. Therefore, these systems are very often referenced to be embedded systems, where it's not so obvious that there's a computer inside, because the main functionality is some mechanical or electrical or chemical process. So the declaration of Gartner Group is operation technology is hardened software that detects or causes changes of physical devices, processes, and events through monitoring or control. Which means we also have computers, but now they are in a different shape. They come in different forms, more like PLCs or even embedded systems with microcontrollers on them. And if we look at the automation pyramid, according to the pretty old ISO 95 model, which has been reused nowadays to see the difference between IT and OT, we can go through 5 layers. So starting at the bottom, there's the production process. This typically deals with sensors and signals. To deal with the signals that come from those sensors, we need some logic controllers, classically referred to as programmable logic controllers, PLCs, the ones that we are using throughout this course. Above this, normally there's some kind of monitoring and supervising, which is called SCADA systems, or some human-machine interfaces, where humans can interact with the machines and where all the data is collected and analyzed and visualized to understand what is going on production level. To know what to produce and in which sequence and from which stock and so on, normally a manufacturing execution system is used, which deals with the shop floor but also with the stock and as well as the manufacturing process. And on top, normally, in most companies, there's an enterprise resource planning system. This is the system that deals with the financial stuff, as well as the sales, as well as the purchasing stuff. And in most companies, those systems are connected, linked to each other, which means that there has to be some kind of interface, some kind of connection, which is most likely to be an internet style, so an Ethernet, TCP, IP, transport control protocol, internet protocol based connection. And while the above three layers are typically handled by the IT department. The OT technology is more dealing with the shop floor and is also mostly dealt with by different people. And this has a significant impact on security and protection. So IT devices like a PC or a laptop normally have powerful multi-core CPUs, they have lots of RAM, and they have a comprehensive operating system supporting a lot of stuff. They have built-in firewalls, normally also antivirus software is installed, and heavy browsers. If you open up a Google Chrome, it will take 1.5 gigs of your RAM. And normally, at least in most companies, an IT department cares about security management, that all the patches are installed on a regular basis, and so on and so on. On the OT level, so production level, there's different types of machines. There's normally PLCs and embedded systems with pretty low computing power. And normally the IT department does not care about these devices because normally they also do not really understand it, and they shouldn't change something if they don't understand the production process, the machines that are run with the PLCs or the embedded systems. Because changes on those systems would result in mechanical issues potentially. Therefore, you need totally different skills. The problem here is that there is mostly no or only low integrated security, which means that this security has to be outsourced to other devices. Just think of the president and his bodyguard. The president has to run the country, but he is not good in self-defense. And that's why he has a bodyguard that just protects him. And this is what we're going to apply to our devices as well. Therefore, we're going to use switches and routers to connect our devices to the internet, to a network, and while we connect them, we also try to protect them. And there's different types of functionalities or some components. So when you start on the layers or on the functionality, if you connect a network, just to connect it, you normally use a hub. A hub is just an electrical device that connects a lot of cables to form one single network. Then you can attach bridges, which just connect two networks, but they are pretty dumb devices. It's more intelligent to switch connections, which means that a switch always connects multiple devices and just connects the two devices that in this moment want to talk to each other. Therefore, the throughput of data is optimized because only the devices that need to exchange information really use the wires that they're connected to or the wireless LAN connection or whatever. In industrial environments as well as in IT environments, not for home users, but in industrial environments, normally these switches are manageable. Manageable means that the access and connections can be restricted. Virtual LANs can be defined, so which means that physically the ports are all on the device, like with this example of a Siemens industrial switch, which has 8 ports. Nevertheless, you can create virtual ports, for example, say, okay, the above 4 ports are connected to have one LAN that is not reachable from the other 4 ports, for example. So you protect individual virtual LANs from each other. Also, this would mean that you can turn off and on individual ports, so nobody else could just plug in some computer and look what's going on the network. Also, devices like this allow redundancy, which means that you have 2 connections to the target, and if one connection is broken for any reason, you still can operate the system because the other connection is still working. And they allow a lot of diagnostics and statistics, which is pretty important for us if we want to manage our network. A router mostly has switching functionality included, like this one, again from Siemens, which is a 5-port router with an integrated switch. So you can use these 5 ports as like with any other switch, but the main functionality of a router is to connect different networks. So the idea is to have one point dedicated to look to the outside, whereas the other ports dedicated to the inside, and they are connected like a switch. So a 4-port switch with a 5th connection to the outside. As you can see, all connections are RJ45, which means all those ports are somehow internet ports or TCP ports, most likely. So there's no change in physical layers, but there's a change to protect one network from the other. Because the main function is that these devices have network address translation, which means that from the outside there's a different IP address visible than from the inside. So you can build up your own local network, and only things that want to go out are changed to another IP address. Also, a firewall is included normally, which means that IP stuff, Internet Protocol stuff that is not allowed to pass through is blocked, and you can set up individual ports and individual routes to make sure that there's no harming going on. And they have, most modern routers with firewalls have some stateful inspection. Stateful inspection means that they really open up the IP packets and look for the content and see whether the content could be harmful for the target network or not. And they also include some DHCP server, which means that IP addresses are automatically assigned for the partners within the network. And because this is a pretty complex system and with a lot of functionality, also the price tag is quite high. Nevertheless, it always pays off to invest more money for the network, because this is a critical security issue normally. Because, as mentioned before, in OT environments, protection is different and also difficult, but it has to be done. It's not very useful if the IT area is totally protected and well managed, and on the OT level, everything is open and everybody can access the machines. And since most of the machines are nowadays connected to the IT in the company and also to the internet to get updates, downloads, and so on, or use a browser or whatever, or send data to some cloud, which is something that is not so new anymore, but very, very important, which means that even an individual PLC has to have an internet connection, therefore it can be reached from the internet. And if you just put a device onto the internet, it takes roughly 3 to 5 minutes until the first person tries to connect to your device. That's our experience. Therefore, you have to make sure that no unauthorized user is able to connect to your system. Therefore, you definitively need a firewall. In the Siemens world, they provide 4 different categories of devices. The S devices, one of those we are going to use immediately, are the security devices. The X series devices are the network devices. I think the X means switching somehow, crossing cables. M is the mobile wireless communication routers, which means that they connect to some GSM, cellular phone network, and wireless is, of course, for wireless LAN. And the interesting fact with Siemens devices is that they support Profinet, which means that they use an industrial bus system to send and communicate all their data, so you can manage them over Profinet. They are also able to forward Profinet packets, so you can integrate them in your production environment easily. And they are fully manageable via the TIA portal, which is totally integrated automation portal. And you can also connect them to the TIA portal cloud, which means that everything is remotely manageable over a single system, a single infrastructure, a single, so to say, ecosystem. And as we said, there's typical applications of a router. And it's mainly switching and routing, of course, beside a firewall and similar stuffs. And there's two layers that we're going to see when we power up our devices. Layer 2 means that we are on a pretty low layer. It is the network layer, which means that we're dealing with MAC addresses mostly. MAC addresses are addresses that are assigned at manufacturing time. So there's a MAC address range given to every producer of network devices, and this MAC address is burned into the firmware or into the flash or into the hardware. And each device in the internet has an individual MAC address. And a layer 2 switching means that it's looking for MAC addresses and the switch tries to connect the MAC addresses that fit to each other. Layer 3 is the layer above, where already IP addresses are assigned. And as you know, IP addresses may change, which means that we have some kind of static and dynamic routing. So if you change the IP address of some device, of course, routing has to change. And you can statically create routes where always a few devices are connected, but you also can do that dynamically. So layer 3 switching deals with the protocol level above, whereas layer 2 is a more easy way, and it's a little bit faster because there's no need to inspect the TCP packets, but with modern switch and router hardware, it doesn't play an important role that much. And to be able to remotely update our PLCs, that's what we want to do mainly, we can set up remote access. We can set up remote access with switches only, of course, which means that we can at least make sure that the right devices are connected to each other, and we have some automation cells, individual cells, that are hidden from each other. This is what a switch also could do, but to protect from the outside, you need a firewall, and to be able to connect even there, though there's some protection, you need some kind of VPN tunnel to pass the firewall. So what is a VPN? Virtual Private Network, where the router and your machine, where you want to connect to the other systems, create a tunnel. Tunnel basically means that there's an encrypted data communication where only two endpoints, your device and in this case the Siemens S615, can understand what is going on, and the data is transferred over the internet, but nobody beside of the two VPN partners, or sometimes more VPN partners, are able to understand what is going on there. So they can't read the information, and this VPN, of course, tunnels also through the firewall, so these VPN packets are allowed to pass through. And the router then changes the VPN, the encrypted VPN information, to be visible for the inside partners as normal network packets that they can understand. So the machines in the automation cells below, they do not have the need to decrypt something, they do not have to know anything. They get their own small single networks where they're happy with, so you can set up the same IP address, if you like to, for all these automation cells, so you can copy machines very easily and so on and so on, and they just live in their own environment, and the router or a switch cares about it, where the router also is able to protect you from what is going on outside. So this is the full picture with all the remote stations outside. As you can see here, the cloud always is some synonym for the internet. And if you do not have a software for virtual private networks, you can also use two Scalance devices to set up this virtual private network, and just to make sure that the VPN is tunneling through. In this example, you can see that there's also an internet router in between. And why is that so? Because the Scalance already is in a router. This router is really there to change the physical layer, which means that the Scalance device is based on Ethernet, standard wiring, twisted pair cabling, whereas the Internet access normally uses some kind of fiber or some kind of ADSL or SDSL or similar techniques to use phone lines and other fiber cables, fiber optic cables. Therefore, the Internet router A and B are there to change the physical layer only. And now we're going to look at the router, and before that we are going to look a little bit at the Siemens switch, because it was also provided within the Remain ecosystem, and it's quite interesting to understand what is going on there and how they differ in detail. Now here you can see the setup of typical industrial Ethernet components produced by Siemens. Quite pricey, nevertheless full of functionality. So what you see is two Scalance routers of type S615, which can be used to set up a virtual private network, as like mentioned before. What you can see is that the second one is not powered because we don't need it at the moment. And the other device is an XC208, and as mentioned before, X stands for exchange. So this is an 8-port switch with different functionality. What you also can see is that there's a lot of plugs down there. For power supply, there's more than 2, and this is because these devices have redundant power supply. Redundant power supply means that you can use 2 different power supplies, and if one fails, the device is still powered. So there's a fallback to the second power supply, which is very important for production environments where the risk of losing communication is high and would be dangerous for the machine or for the system or for the production. So stopping a production never is nice. These devices are supplied by a power supply. In this case, it's just a single power supply, but this is enough for testing. What you also can see is that the devices offer a input and output, which means that you can use a switch to activate some functionality, and you can also activate some output. So there's some electrical connection where you can do something if you want to do remotely or if some state changes. For example, with the input, you can ask for a log entry, or you can set up some value, or you can start up a virtual private network. So you really need to go there physically, so you can be sure that there has to be some person that really says, I now want to start the VPN. Whereas the output could be useful to give some signaling on some errors, for example, that you then could connect to your PLC or to a machine or to a lamp, so everybody sees that there is an issue with the system. Both devices are connected to another wireless LAN router that is used just to connect from the computer to set the devices up. Setting up means that you need some IP connection to the device and use a browser to set the necessary information. Devices like these have a lot of functionality. So if you're going to play around with this stuff, it is very likely that you misconfigure it, at least in the beginning when you're not so familiar with the system. Therefore, the most important functionality that you should understand right from the beginning is the functionality of the buttons that are on the devices. There's one small button on this device as well as one small button on the other device. Functionality of this button is easy explained. I'm going to push this one. You see that the LED gets red, the LED on top, then starts blinking. While it's blinking, it would wait for a TFTP connection, which means that you could upload a firmware over the internet because it's waiting for a connection of the thin FTP client. And when it stops blinking, it turns red, steady red, which is after 10 seconds roughly. You can release the button, and then the device does a full factory reset, which means that you can restart everything from scratch, which is good if you're just trying to learn something and understand how these systems work. As you can see, it takes quite a lot of time until the device has rebooted. Nevertheless, it's still set back to factory defaults. If you want to understand how to transfer this stuff to other devices or how to make sure that you can exchange this device. It has a security on the bottom, so it's hidden underneath the device, so you have to remove it from the rail, and you can take this plug out and plug it into the next router. So if you have a hardware issue with this device, and you have all the settings on this plug, which basically is a memory card, a hidden memory card, you can remove the device, pull out the plug on the back, put it into the next device, and start again. And all the settings are taken over to the next device, which is pretty helpful. As you can see now, it has rebooted, so it's ready to connect. Both devices are connected via LAN cables to a wireless LAN router where I can connect to set the devices up. For setting up, a browser is necessary, and this browser just connects to the HTTP or HTTPS interface of the network devices. The switch uses DHCP, so the DHCP of the wireless LAN router in this case, to get an IP address. Therefore, it can be reached under the internal address 101, and the user and name and password at the beginning is admin. And if you enter this, you get an information that you should change this default password immediately, and you have to. So if you just click login, you have to wait a little bit, so it's not very fast, but anyway. And the first thing that it asks is a new password. I'm going to type in a new password, and you have to repeat this password twice, of course, to make sure that you do not enter a second different password. And when you set the values, the new password is stored, ideally, and you're logged onto the system. In this case, we are connected with the Scalance XE208, and there you get all the necessary information to the left. So you get all the information that you would like to see, as well as the information about the system, and then you can set up layer 2 and layer 3 like mentioned before. So for example, you can set up virtual LANs, like port-based virtual LANs. In this case, like expected, nothing is in there because this device, when it powers up with factory defaults, connects every port to every other port, no virtual LANs, no port filtering, nothing, just to make sure that you're able to start up the device very easily. Which means that all the ports are similar, so you can connect your initial device just to do this setup to any of the 8 ports that you would like to. And then you start to dig into further depth and set up all the deals. As you can see from the menus to the left, layer 2, layer 3, there's a lot of things that you can change and set up. What is also important is that there's a lot of security functionalities, for example, that you can define user groups with individual access rights. So it's a good idea to create groups like administrators or just, normal IT people, and they get different levels of what they may do. So for example, a normal user that just needs to understand what's going on can be allowed to access read-only, which means that this person may see all the data but may not change anything in the device. Whereas a power user may change certain things, whereas the administrator will be the only person that is allowed to introduce new users and similar, or the user groups and similar stuff. And everything that you could do on this interface can be logged, will be logged. You can do that via Profinet, and it is really, really powerful. So there are a lot of options, but the details would go far beyond that course. It's more about networks and understanding them, but there's other courses in Remain that deal in depth with that. And next device that we're going to look at is the router. Like the Siemens switch, also the Siemens Scalance router, when set back to factory defaults, allows to connect to any of those ports to configure the device. And when you then activate LANs, virtual LANs and similar stuff, then you will be restricted. So normally it would be a good idea to connect to port 5 because this is the port that is meant to be from the outside. But in this case it doesn't matter because configuration could also happen from the inside. And again, you have to log in into the system and like always, the same password and name has to be applied, which is admin. And again, on this device, the default password must be changed. Something that you just should understand is that this router can be reached under a different IP address, the 1.1 address. This is because it is a router, and normally the router has also the task to offer DHCP, so deliver IP addresses to the devices that are connected. And there, it's quite normal that the router has the 0.1 address in a smaller network like the 192.168 network. Therefore, it has a fixed IP address already on boot up, just to make sure that you know that you can connect to this device if you want to set up a network from scratch. Therefore, this address is not taken by DHCP, like with the switch, but it's already fixed in the beginning. Of course, you can change it also to a DHCP, but it's just worth mentioning it. And again, you have to change the default password, which is the same mechanism like before. Again, you have to retype the old password and then type in a new password. You are forced to do a rather secure password, which is not so good for testing, but it's okay. Okay, so what you can see here is the device now transitioned to operational state because changing the password is mandatory in the beginning. Now it's fully working, but all the setup functions are disabled, again, for security reasons. Reloads the page, and you can start with setup of all the details. Unlike the switch, you are guided to a basic setup right in the beginning, like it is with most of the home routers that you can get. So therefore, you have to check whether you would like to do that. So you see there's some internal LAN, the VLAN number 1, and then external VLAN. The external VLAN should provide DHCP. We like that, so we click on Next. Then we could give a name to the device, which is something that you normally really would like to do because you can then identify the device much easier. Next step is to check to set up the time, which is also mandatory because otherwise the log file doesn't have any meaning. In this case, we cannot connect to the internet, therefore you use the time of the PC that we are using to set this up. Dynamic domain name service is not important at the moment. Cinema is something that we should mention. Cinema is a complete system of Siemens to manage networks and everything. So it's totally integrated again. In this case, we don't have Cinema installed somewhere. Therefore, we can click Next again. Then we could have some cloud connector using Profinet. So the same mechanism like our PLCs will do, at least our Siemens PLCs. We can connect with one of those interfaces, and then we click Next, and then we're going to store the information with the set values button. And now we're good to go with the basic setup of the router. And like expected, also takes a little bit, also the security functions are similar to those on the switches, as well as there are extended things like routing protocols. So in the beginning, setting up all this stuff takes a little bit longer. And when we finally have set up everything, we can continue setting up the rest of the system. Finally, you will reach the Start menu, and there you can set up everything that is interesting for you. In this case, things that we should just mention is that we'll look at the interfaces, especially the virtual LANs. where you can see that there are two virtual LANs set up automatically, one for the internal stuff and one for the external stuff. So you can see that ports 1 to 4 are reserved for the internal network, whereas port 5 is meant to be used from externally. And if you create such virtual LANs, you then can start to create firewall rules, which is the most important thing with setting up such a router, because the firewall functionality is what makes your internal production cell networks secure to get them protected by the router. Which means that for each production cell that should be on its own, it is good to create an individual virtual LAN to make sure that the production cells cannot interfere with each other. And different from the switch, the router offers a security menu that has all the necessary stuff to deal with certificates, firewalls, and virtual private networks. And just to open the firewalls, so what you could do here is to have some predefined routing, which devices may connect to which. So it's just a basic setup, and which protocols or functionalities are allowed on which virtual LAN or which port. So which means that, for example, DHCP is allowed on certain things, and so on and so on. And then you can create rules, and you create individual rules. You can create rules based on services, but also based on IP protocols or on IP rules. And the best idea, of course, is to just start with a basic internet protocol rule where you just make sure that you start dropping everything. So it's a good idea to block everything in the beginning and then open up only the protocols that you would like to see. This is a cumbersome process because sometimes you make mistakes and so on and so on. Nevertheless, the safest way always is to start with a fully blocked system. It's the difficultest way, but it's the safest way to block everything and then start to open just the functionality that you would need on your device to connect to other devices or whatever. A few final words about what you should set up in the beginning, or you should at least check in the beginning when configuring the Scalance S615, is maybe you should set the automatic logout timeout a little bit higher, maximum 3,600 seconds, so you do not have to enter the password very often. Also, you should be aware that you can turn off the restore factory default functionality of the reset button. If you turn it off, it's really cumbersome if you forget about the login credentials. You can remove the plug, and this is something that you also should consider what to do with the plug, so configure the plug. As you see, the plug contains a configuration and a license. So you can store your current configuration on the plug. As mentioned before, you just take the plug and put it into the next device and it gets the same setup. Nevertheless, you have to remove it from the rail to be able to do that. So think of whether you should like to store stuff on the plug. It also can come with some license from Siemens, so extended functionality, and the plug just activates this functionality. The device will work without the plug, but in this case, everything is stored on the device, which means that if the device is broken for some reason, you have to reinstall or reset up everything on a new device. Also something just to mention, hardware input and output diagram. Of course, you could read the manual. Nobody reads the manual. That's why I'm going to mention it here. So it has those functionalities, and this is very valuable if you could plug that to a bigger machine so you can activate the output at defined events, and the input functionality is, for example, to start a VPN. And this will make you totally sure that a foreign person cannot activate or log on to the VPN. For example, you have a machine in your manufacturing network and somebody asks for remote access because he or she wants to do some maintenance. With this functionality, you really have to push the button to open up the VPN. And finally, something to mention, the Siemens connectors you can connect to the TioPortal cloud, where you can do all the engineering in the cloud and upload it to the system. And we already also mentioned Cinema RC management platform for remote networks. Nevertheless, finally setting up all the stuff that is necessary for a VPN and setting up all the firewall functionalities, all the VLAN functionalities and everything can be a cumbersome process and will be the content of lectures of other partners in the Riemann network, or you go to attend some lectures about setting up networks, which is super interesting, but another topic. Thank you very much and have fun with the PLCs.